our trying to understand indigenous mixed cropping systems goes back a couple of years ago. So we had this Tigress project which gave us some space. I have a colleague from the Tigress project here also. So there through WASN, through RRA network, we tried to get partners who have been who have some understanding, some knowledge, or trying to get to farmers who are practicing or had practiced in some time in the past. So to understand those structures. But before I get into this structure, I will try to reiterate. You have reduced the time to 12 minutes.
Yes.
Okay. So okay, I'll keep that in mind. So we generally when we started thinking in RRA network or similar initiatives in Odisha, Malay,
Switch on your mic, please.
when we are talking about cropping patterns, mixed cropping patterns, we generally try to see here what are the vulnerabilities or intersectionality of vulnerabilities, and trying to see how we can policy or any decisions how can address those vulnerabilities. Here the vulnerabilities we are talking about mixed cropping systems vis-a-vis monocropping, or marginal rain-fed areas vis-a-vis irrigated areas, or vulnerable populations who are involved in these areas vis-a-vis people, those who have access to better systems, better institutions, or better schemes by the state. So the mixed going to mixed cropping systems. Mixed cropping systems is actually working with multiple dimensions. If one wants to bring in, you talk about generally when we think about agriculture, or as a layperson we think about agriculture, we think ek kheti hai, and in that we sow something or you grow something. The length and breadth that matters. But here your root, जो जमीन के नीचे, that also matters. जमीन के ऊपर, how you use that horizontal space, that matters, and how you use vertical space, that matters. So, and the time matters not only in terms of how you use how there will be green coverage for a longer period of time in a year, but there can be changes from year to year. So like mixed cropping doesn't mean that what we are doing this year we will end up doing the same thing the next year. It could be something else. So the space-time interactions are quite complex here. And there are, and this note which is already circulated you, I'm trying to reiterate those things. So these are the design principles that came up. Like we reached out to various partners in the RRA network, and some of them could help us document practices still happening or practices which happened in the past. They could help us document. Based on that, we found some of them which are common. One is there is diversity in crop and variety, like not only one single crop or two, there could be multiple crops, and a particular crop could have multiple varieties. Like if you are doing ragi may not be one type of ragi. There could be various varieties of ragi which is grown in the same plot of land. The phenotype that we are talking about is the unique characteristics which are very important for that ecosystem. The traits that those crops and varieties have. The other design principle that comes to our mind is that one time sowing is done, and then there will be multiple harvesting that will come out of it. And so that along is the harvest. At the sowing period we reduce transaction costs. On the other hand, because we allow harvesting to happen at multiple times over the year, then it also means that people are engaged for a longer period of time in their own land, which has its own advantages. And because of mix of crops, there is an the soil health is, because a particular crop may take certain nutrients from the soil, but it gives back another kind of nutrient to the soil. So this mix and match, the balancing out, helps the crop mix that the farmers practice, or the practice happens in an ecosystem, helps the soil health. And for the same reason, we have these crop mixes also are pest and disease management. Sometimes we may grow a particular crop because they will attract a particular pest, and that pest there are two functions that this could happen. One is that it will prevent the pest going to the main crop, or it could actually attract a pest which is a friendly pest. which will prevent the harmful pest from coming in. So there are various combinations, but this crop management itself, the diverse crop management, could be a natural pest and diseases. There is resource use efficiency. Here by resource use efficiency, we can talk about three things: rainfall, soil, and land. And how rainfall use efficiency is there, I will elaborate as I go, because how in single crop we sow, we harvest, and that's it. But when it is a multiple crops are there with multiple harvest things, the harvesting can go longer. So rainfall is used for a longer period of time. And then there is also soil use efficiency, because different crops may have different root depth, and so they may use different aspects of the soil, and this also adds to the soil nutrient health to some extent. Uses soil and also adds to the nutrient. Land, we will talk about, I will elaborate a bit as I go about how land efficient rate could be. Saving on land use, if you would have just, if all my food needs a balanced diet, if a food need is required, is grown, I may need more land to grow the same amount of food. So then like this polycropping structure that you see in your notes here, it is nutrient dense. Many foods are grown in the same land, so it is adding to your food and nutrition security. And then there is also fodder security. So to reiterate all that I have showed, so this is diversity in crop and variety. You see this Hangdi Kheti from Rajasthan, or Sat Gajra system, that is still prevalent. These are still prevalent in some of these areas, Madhya Pradesh. So all these different kinds of seeds are grown. Like Sat Gajra means 7 different seeds are put. There is another system where is Bara Anaj, they put 12 seeds at the same time for sowing. So the phenotype, as we see that unique characteristics, but from the crop varieties that one is grown, you will see also their heights are different, their type, some are creepers, some are climbers, some are bushy, some are shrubs, some are erect, some could be even trees also can come into these structures in some of the multi-cropping systems. And then duration of harvest is also different. Some is 5 to 7, 8 months, or different periods of time will be there. So these things, and as these are grown, they can help add your food security, because different nutrient compositions, all this. If you look at the phenotype that we have given from one of the examples, this is Akadi from Karnataka. The right side phenotype you see is Akadi system from Karnataka, again being practiced. So each of these crops that are there, they have different nutrient components, or some are good in pulse, some are good in protein, some are good in some other macro and micronutrients that we will have. So, and they will have fodder security. The point on water use efficiency, I think I will, one time sowing and multiple harvest is quite very clearly coming out from this picture. We have different crops. Some crops can have multiple harvests, like the creepers that we have shown there. But some other crops have different times of harvesting. So you have a longer harvest. So in a single monocropping maize, which is also prevalent in this is Olia system from Madhya Pradesh. If only maize is grown, which is a dominant crop, so the first red line that you see, so after the harvesting of the maize crop, the land remains fallow. But in this multi-cropping system, only around January to May, you will find the last red line to the right that you see, you will see a fallow period being shortened. So how one time sowing and multiple harvest is also linked to soil health, pest management, and resource use efficiency we saw there. And I mentioned to you about the soil health. You see that the different plants can have different depth of the root and take advantage of the different nutrients at different depths in the soil. On the right hand side panel, we have used how land use efficiency can be there. Now if there are 2 crops, suppose there are 2 crops being grown to make the calculation sound easier. So there could be many more crops. So then how do we calculate yield? The yield calculations under these structures can be much more complex, but suppose we want to compare between a conventional yield with this structure. So then what we do is that we calculate the yield of the crop in a mixed. This is from the we are, I think Debal Dev's study on LER from one of the Orissa experiments. So if it is a mixed cropping system, what is the yield? And if that crop would have been grown in a nearby system independently, what would be yield from the same unit of land? So we divide these two yields, we get a LER for that crop. And if we get LER for all the crops that are grown there, then that should be, that will give us the overall land equivalent rate. And in this particular study that was shown, I think the land equivalent rate was about 1.3 to 1.86. That means you would need around 30% to 80% more land to cultivate same amount of the product produce. And multiple produce. See, the other thing is that when I put it in this, before I conclude, when I put it in this LER, it will look like okay, only food. But if you are growing food in a multi-cropping system, your nutrients that are coming out from that is much different. Your soil health is much different. So that symbiotic relationship that it brings out is nothing that is captured in this LER. LER is just trying to help us understand how yield is captured. In that sense, if we are capturing, but there are many more dimensions which are not capturing through just LER. So to sum up, so what are these mixed cropping systems giving us? So they show a symbiotic relationship of agroecology between land, livestock and livelihood. So though we just showed the crops here, there is a livestock part to it. See, many of these crops that are grown, they are grown for food and also fodder. So that means we have livestock, and your land provides food and fodder to food for the human beings or people who are putting in effort, and also livestock. Livestock is providing manure. Human beings put in effort to both these things. Now these kind of symbiotic relationship that we saw, we see is also happening between plants because of their shoots and roots giving a nutrient help to each other. So the symbiotic relationship actually in an agroecology fans out in much more complex ways than that we can understand. And these are not marketed, these are not transacted. So as we said, no, when things are not transacted, they are not captured, but they do add a substantive value to your agroecology. And what are we doing when you are doing this multi-cropping? We take advantage of the multiple dimensions. There is a horizontal dimension which is area covered, length, breadth. Then we also have the vertical space, which is not only below the surface of the earth, but vertical layer above the surface of the earth. Some are 2 feet, some are 4 feet, some are 6 feet. So different crops grow to different heights and take care of air, sunlight and water from below or moisture. So they take advantages of different things. And in some places, like I think Somik will be talking about that, so I'll not be elaborating on those things. But he will speak of a system where you don't talk about only the first year, the second year and the subsequent years can have different understanding from the time component. There are year-to-year changes that we will be getting out of this symbiotic relationships. So these comparisons from various about 10-12 studies when we were doing the Tigris work, and then more in the last 1 or 2 years we have reached out to some more. And this comparison gives us these design principles. We are not saying that this is a complete, there could be something that we have missed out or we could not articulate properly. But one policy ask from this thing that is coming out, and which is largely what RRA network has also been working, and as the moderator Professor Raina spoke in the beginning, we require knowledge intensive support of this. The knowledge dimensions are so complex within agriculture, and then if I go beyond agriculture to incomes, to marketing or to other domain dimensions, they actually open up dimensions which are beyond a single knowledge or single dimensions comprehension. So we need knowledge, and this knowledge intensive support could be location specific. It's not that it is one size fits all. Like if we can do something for understand something for Sat Gajra, that would be relevant also for in terms of practice. In terms of design, yes, but in terms of practice, that could be much more complicated for Misa Chaso or for Olia, or what is happening in Koraput could be very different from what could happen in, say, Malkangiri. So I think these are, with this I'll stop. Thank you.